Hello, brave students. This is lesson 25, Do I Have Enough Reactant? So the book tells us we're used to being given an amount of reactant to see what type of product we can produce. So we're going to do the opposite. We're going to say we want to produce this much product, how much reactant do we need? And it works very well to use an analogy of a recipe. If we want to make 6 dozen cookies, we have a 2 dozen cookie recipe. We know that we have to triple the recipe in order to make 6 dozen cookies. We're looking for a certain product, and we need to know the amount of reactant or the ingredients. So then we look and see if we have enough ingredients to triple the recipe. So we're going to do that with chemical reactions. So the first example we have is the ammonium nitrite that degrades into water and nitrogen gas. And the first thing to do, of course, is to get the balanced equation. And if this doesn't automatically happen for you at this point, I balance this equation. We'll balance it together. We'll balance this equation together. There's our ammonium nitrite into water and nitrogen. This is our ammonium, this is our nitrite, this is our water, and we know that nitrogen gas is a diatomic gas, so it's always going to be 2. When we put our components down, nitrogen on this side, there's 2, 1, 2. On this side, there's 2 nitrogens, so we're good. Hydrogen, there's 4 on this side. There's only 2 on this side. And oxygen, there is, where am I? 2 on this side, and there's 1 on this side. But this is an easy fix because we need 2 more hydrogens anyway. So we're going to make the H2O 2 of them. That brings our 2 hydrogens on that side to 4, and it brings our oxygen to 2. It balances our equation, and it looks like the equation in the book. Then they put their 1s in front if they need to get their mole ratio, and it's a 1-to-1 mole ratio. In this case, when you have a 1-to-1, if you want 5 moles of something and it's a 1-to-1 ratio, you need 5 moles of the other thing. So 1 mole of nitrogen gas takes 1 mole of ammonium, so 5 to 5. Now in the second example, we started again with potassium perchlorate, and you have to start with that balanced equation. If that doesn't automatically balance in your mind, we'll go ahead and balance it together. Here's your potassium perchlorate. Here's your potassium chloride that it degrades into, and your oxygen gas. Potassium perchlorate is straight off your